Hi, I'm John Genke, and welcome to Live from the Lab. During this series, we explore different technologies that Bruker has created in order to help scientists understand the world around us. Today's topic is X-ray fluorescence, and I'm joined by my colleague, Julia Zettelmeyer.
Good morning.
So in the past, we've talked about X-ray microscopy, which is a technique where we kind of looked into the sample, we saw the structure on a large scale, and then we looked at X-ray diffraction, and that saw the structure on a smaller scale. But X-ray fluorescence is kind of completely different, right?
Yes and no. I mean, we also look into things without with X-rays, but instead of the structure, we get information on what is in the sample, what type of elements are in the sample. Is there sodium in there? Is there magnesium in there? Is there lead in it? Or iron or calcium? Any kind of element that you can think of, we can probe with X-rays.
So yeah, I mean, for maybe some of those out there, the world around us is made up of a bunch of different atoms, and they come in different flavors. There's a little bit more than 100 of those, and we call those elements. There's a big table of them called the periodic table. And XRF helps us to identify which elements are present, correct?
Correct. And the nice thing is that it also does it without needing any specific sample preparation or very elaborate sample preparation. And in most cases, it also is non-destructive.
Okay. So now you said that you mentioned that it uses X-rays.
Yes.
So how does that happen? What is this kind of the story of X-rays?
So what happens is we have X-rays coming from a source that interacts with the sample, and then it goes into a detector.
I think we have a little drawing here.
Right. Thank you. And it is that simple, but it also can be made a little more sophisticated. So we have two different ways of using XRF analysis. We have EDXRF, which is energy dispersive, and WDXRF, which is wavelength dispersive.
Okay.
And you can see the beginning is the same. So we have a tube, and it has energy or X-rays coming out, and then it interacts with the sample. What happens is it activates basically the fluorescence of the elements that are in the sample, and then we have a detector that reads it out. If we talk about wavelength dispersive, we have a collimator that helps us to guide only the parallel beams to the crystal, and the crystal does the resolution for us. So here we need to have a very good detector in energy dispersive, and we actually do have a good detector with our S2 Puma. But if we need more distinction between peaks, if we have a lot of elements, then a crystal can help to improve that resolution even more.
So the smaller machines, kind of, I know I've seen on other shows like handhelds where they walk around and they'll just pull a trigger, and
right.
That's more this type, this EDX, right?
Yes. So you see, this part is fixed, whereas here we do have moving parts. It can be a handheld, but of course, if you have a larger system where components are fixed, it's tuned better, and you do get better resolution, and you do get better results with a standing or a benchtop model.
Okay, so this tends to be benchtop. Now, WDXRF, I guess when I've seen those in the past, I think about these really big machines that kind of occupy a lot of lab space.
Right, they used to. I mean, the one that we want to talk about today is also a benchtop system, so it's actually the same size as our EDXRF system. And we made the beam path very compact so that everything fits into it, and it's actually a good thing to make it compact, because that way everything's closer together and we get higher intensity.
So it looks like you had brought a few of the parts that we're actually seeing here.
Right, we did. So this is what a collimator looks like. This is what paralyzes the beam, and you can see, oh, this is kind of hard with the camera. No, this way. Only if I have it really parallel to your camera, you can see through it, right?
Oh yeah, yep.
And then the crystals, we do have several crystals depending on what elements you look at. This one is for heavier elements, this one is for lighter elements. So because the periodic system is very big and we do have a lot of energies to look at, we can't, it's better to use different crystals because we only have like a finite space where we can reflect off to.
So then with a machine, would I have to stick in this one if I'm expecting heavier ones, and then take this out and then stick another one in if I'm looking at the other elements?
No, we have in the S6 JAGUAR, we have space for 4 crystals. On the S8 Tiger, we have actually space for 8 crystals. But 4 crystals is pretty much all that you need if you want to look at everything. The nice thing is, if you just are interested in a certain range of elements, you can just buy one crystal if that's what you want, and you get, as I said, the nice resolution.
Okay, and then at a later time you can add more and more crystals if you.
Yes, because this is
Yeah.
actually a magnetic mount. So once you get your crystal, either somebody from us will install it, or you can be talked through about installing it yourself.
Okay, so I think what we have is we have a video about this instrument, the S6 Jaguar that you've brought along. So we're going to switch over to that. So here we are in the XRF lab, and now I've been joined by Dan Picard.
Hey, John, how's it going?
Pretty good, pretty good. So we have quite a few instruments in here. So over here I'm seeing very small units.
Yes, those are our energy dispersive X-ray solutions benchtop units. This is called the S2 Puma.
So yeah, we saw a very, very simple design in there where it just has that energy dispersive detector then.
That's correct,
Okay.
yes.
And then over here I see more of the conventional WD unit that I'm used to.
That's also correct. This is our wavelength dispersive S8 Tiger, which is a forward-standing model, of course, and it's available in 1, 3, or 4 kilowatt.
Okay.
That's for power.
And then here now we have this compact benchtop.
Yes, and this kind of fits the middle part between the energy dispersive and the forward-standing wavelength dispersive system. This is called our S6 Jaguar, which is our benchtop wavelength dispersive system.
So what kind of people, what industries might be interested in a machine like this?
Yeah, this instrument can be used in a lot of different industries. It can be used from anywhere from the universities, academia, to like remote sites like mine sites and stuff like that. We have them in the steel plant, petrochemical, pharmaceutical. So the people that use this instrument is in a wide range of industries.
Okay, so it looks like we actually have a steel sample right here. So if I was a steel customer, what would I be interested in about this sample?
So if you're running that sample, you're looking at the elements that are present and how much of the element is present. As an operator, you basically just have to put it into the system, press a button, and you get results.
Mm-hmm.
The method development that's done beforehand is usually done by the expert user or by an app scientist that comes on site beforehand and stuff like that. Would you care to take a
Sure.
shot at it and run it for us?
Yeah, so what do we do? So I got the sample here. It looks like it's just kind of a puck.
Yep. So why don't you lift the lid up,
All right.
pick a position and put it into one of those rings that you see there.
All right.
Okay. And then before you do anything, click on the position A1 there, which
Okay.
is the same position you put the sample in.
There we go. Good guess.
And then you have an option of what method you want to run it on. Is this a slag sample or is this a steel sample?
This is a low alloy steel, I think.
So, okay, so let's go ahead and press that button.
Okay.
Give it a name or
All
the
right.
sample
Let's
ID.
just say live. There we go.
Okay,
And then we'll hit next.
correct.
And
press-
calibration method. Yes.
Just press
okay.
next, yeah.
Next. Here we go.
So close the lid down here.
All right. So we'll close the lid.
And the last thing you have to do is take that sample from the tray, put it in the instrument to run it. So press the start button right here.
All right. So we'll hit play.
And then the sample arm is going to go over the sample. It's going to lower the arm down and pick up the sample. It's going to bring it over to the X-ray chamber. It's going to lower the sample into the chamber. Raise the arm back up, go back to its home position and shut the X-ray door.
So with that door closing, now that's kind of radiation safe. So we don't have to worry about any sort of irradiation out here.
That's correct. These instruments are 100% safe. Never have to worry about any exposures or anything like that.
Okay, and once that sample is done, once the run is complete, and the sample comes out, does it have any X-rays on it or radiation?
No, it's very safe to handle afterwards.
Okay.
So as soon as it's done running, you can throw in the trash or you can put it back in your desiccator, whatever you want to do with that sample.
Okay, so we don't have to worry. The sample is completely unchanged and it's kind of non-destructive in that regard.
You're right. You can actually run that sample over and over again if you wanted to.
Okay, if we wanted to check historically what was going on.
Yeah.
So then how would I see the actual end result, say, of a measurement?
So on here, we have our touchscreen. You can
Okay.
actually view the results on the external computer or the touchscreen. And what we can do here is if we want to look at archived results, we can just go to the results gallery and you can look for the last hour, the last day, or you can do a advanced search if you want to as well. So this is where you can come to get your results. If you want to look at another sample, you just simply click on it, and it will show you another sample, and then you can click back. As easy as that.
Okay. So Dan, actually, before I joined Bruker, I worked in a steel place, and we used to have a whole bunch of samples, right? Because you have different customer batches, different alloys, and I would have to check them all at once. Is there a way to kind of load up a bunch of samples at one time?
Yeah. So if you have say 20 samples, and you have this tray completely filled, and after you're done running, you want to load like another 20 samples, you can grab another tray, which we have right there. You can take this tray right out, and you can load your next batch right in.
Oh, wow. And it looks like there might even be a cutout back there, too?
Yes, and that cutout is meant for automation samples. So there's some industries that they have a belt going to the back of the system. That belt will come right back there, and the samples will come in through that belt, and the sample handler will pick it up and put it directly into the chamber for you.
So that might be somebody in cement or something like this, right?
That's one of the main industries that uses it. Yeah, cement industry and maybe some geological places as well. Yep.
So what does somebody in cement look for in a machine like this? Like what are they actually trying to measure?
Well, for cement, there's an ASTM norm called C114,
Okay.
which they like to follow. And so we follow that guideline for the analysis. So they're looking from elements from like sodium, magnesium, aluminum, silica, phosphorus, potassium, calcium, manganese, iron, like those elements in their samples.
Okay, and their customers, the cement customers, might actually be looking for that analysis to make sure it dries correctly and cures right.
Yep, all that information is important for them to do what's right for their cell, for the cement. Yeah.
All right. Well, thanks for showing us the instrument.
Yeah, no problem.
We're going to head back over to the studio, and we're going to answer some questions. All right, here we are. We're back in the studio. Now, if you have any questions and they don't happen to get answered here, email those to live.events@bruker.com. Also, if you like what you're seeing, make sure to like, subscribe, and share. So the first question comes from Melissa. What elements can you measure with WDXRF?
Thanks, Melissa. That's a great question. We can measure with WDXRF anything from boron to americium or americium. But with the S6 JAGUAR, anything below fluorine is not practical.
Okay. So that's pretty much the whole periodic table.
Yes, it is.
In terms of, I guess you could say useful almost, right?
Yes.
Some of those
very
higher,
useful.
yeah, some of those higher ones, they only exist for like nanoseconds or something once they're created.
Correct.
So the next question from Nick, what type of samples can we measure with the S6 JAGUAR?
Sure, I'll take that one. Thanks, Nick, for your question. So we can run all different types of samples in our instrument. So if you want to start with a powder sample and run that with a liquid cup, you could. You could add a binder to that, and you can press it into a pellet if you want to. Do we have a pellet here? Yep. So here's an example of a pellet. And then if you want, you can fuse the sample into a glass bead. You could also run the sample as a liquid that we see here in a liquid cup. Oh, here we go. Here's a fused bead right there. You have everything for us. So here's the fused bead. And you can also run it other ways as well. So the main thing with the sample prep is that that sample has to fit the ring that is provided with the instrument. There's a max diameter of 40 millimeters right here for this type of ring. And if you turn it around, we can go low or smaller with the diameter right here. So this is a 34 millimeters, and we can get down to 18 millimeters there to mask it off. So there we can do different types of samples and different sizes of samples.
So does the sample have to be flat to use XRF?
Yes, you would definitely want to have the sample flat. Any irregularity in the samples can change the intensity. And so you want the samples to be as flat as possible so that you have that consistency between the unknown samples and your calibration standards.
Okay. Now, it does look like you have liquid in this one, though, right?
Yes, I'm not sure which liquid's in there, but we do have something.
Something blue. And then on the bottom, is it some sort of like a very transparent material or something?
Yeah, so that's a film that we use. There's a lot of different films on the market. There's Mylar, there's Proline, there's Kapton, there's a whole bunch of different films. And there's the reasons why you pick one film over another film. It could be the type of material that you're running so it doesn't attack the film, or it could be what element you're looking at. So each film will absorb X-rays. And so if you're looking at lighter elements, there's films that are better for those lighter elements like sodium, magnesium, and stuff like that, versus heavier elements, where it doesn't really play a factor in.
One other question I actually have, I've heard that sometimes you do XRF under vacuum, sometimes you can just do it in air. Why would I do it in different ways?
Do you want to take that?
I'll let you talk.
Okay. If you have a liquid, you do not want to measure in vacuum, because what happens if you pull a vacuum on a liquid, it ends up all over your chamber. So in that case, we would use helium, because helium is light enough so that light elements can be measured. However, if you want to measure something like lead or even sulfur, you could measure it in air. It's good to always use the same type of air. So if you are in a kind of dusty environment, then we obviously don't take the air from the outside. But yes, the reasons why you choose a certain mode is to increase your intensity and to protect your sample.
Okay, so unlike some of the electron-based techniques, here we can actually operate in that different environments,
right,
if we feel like it.
Right.
All right, so the next question from Chris. What options do you have for different analyzer crystals?
I showed two crystals before. I showed this one and that one. Now you don't know what these are.
No, I have no clue.
So we do have 3 default crystals, which are used if you want to also use our standardless method. But the nice thing about it is they They're standard default crystals. They cover the whole periodic system. We have one for the light elements, one for the intermediate ones, somewhere between aluminum and you can go up to calcium, but actually at that point we would switch to the crystal called LIF 200, and that does all the heavier elements.
So then each crystal kind of optimized for a certain element range. If you want to cover everything, you need about 3 of them?
Yes. For the S6 JAGUAR, you can just choose to go with one crystal. If, for example, you have just one analysis that you do, if you just do sulfur analysis or just phosphorus on a film, then you can just choose that one crystal. We do also have some other crystals available, like the X6 400 that covers pretty much the same range as the LIF 200, but it has high intensity. We do have, we do have crystals that make the heavier elements make the resolution better. And on the S6, as I said, we have these 3 default crystals, but the crystal changer has 4 positions. So you can get those 3 to use a standardless method and cover the whole periodic system. And then you can get an additional crystal that improves the resolution and the intensity on elements that you are specifically interested in. On the S8 Tiger, on the other hand, we have space for 8 crystals. So there you can get the 3 default crystals plus whatever else you want.
So now you mentioned this standardless, and then there's also a standard-based technique, right? Those are the 2 methods. So what's the difference between standard-based XRF and then standardless XRF?
So standard-based is where you provide the standards. So you have a product or a material that you want to measure. You also have standards that you measure. So what Dan mentioned before about if the standard has to be, or if the samples have to be flat, we want our standards and our material to be prepared the same way. So for example, you want to measure powder, you get some standardized certified reference material of that powder, you measure a curve or you measure the intensities, and then you can compare the intensities of your unknown samples to these intensities of the standards that you have.
So you measure a series of known materials with different concentration and then...
Correct, and then you can calibrate your system. The standardless method is calibrated by us. It's very general, but it gives you a very good estimated guess, educated guess of what is in your sample. It helps if you, for example, have some, I don't know, some dirt that you find in a pipe and you really want to know if something leaked out of it, then you can put that in one of these cups and measure it.
Okay. So on like a Jaguar, you could actually have both methods set up?
Correct.
Oh, wow. Okay, so you can do the more qualitative standardless or the very quantitative standard-based.
Correct.
All right, next question from Andrew. Is it possible to transfer results?
Yeah, hey, Andrew. That's a good question. Yeah, we do have a lot of customers that when they're done running the sample, they want the results transferred to somewhere in their network base and be picked up by a program like LIMS or level 2 or QMOS or something like that. And our instruments, all of our instruments are very compatible with transferring results from the instrument to somewhere on the network in a format that is capable of them capturing and sorting it out the correct way. So that's a very common practice, especially like in the steel plants or geological sites and other places as well. So it's just a nice feature to get the results out to everybody and everyone can see the results as soon as they're done.
So the Jaguar is a very small instrument. Is it actually capable of doing analysis right on board? Or do you need to have an external computer?
So the touchscreen on the Jaguar is optional.
Okay.
So there's a lot of optional pieces to this equipment, which makes it really nice. Julie kind of talked about you can go with one crystal or one detector for certain applications, but there's a lot of optional parts to this, and the touchscreen is one of those optional parts. If you get the touchscreen, what's nice about this is that you have 2 different modes. You have an advanced mode, which you can build calibration, do advanced things, and that's called spectral elements. And then you have a easy operator mode, which is called touch control. Basically, it's like working at ATM. Even you ran a sample with that one. So
push the button.
Exactly,
there we go.
Right. So that's so if you get the touchscreen, you can log into either one of those 2 programs. However, if you don't get the touchscreen with the Jaguar, everything is compatible with the external computer. And you can have the external computer connected to it with the touchscreen, or obviously, if you don't have the touchscreen, you want the external computer connected to it. So.
Okay. And you mentioned that connection to the LIMS database. So you can set it up so it'll actually, as I make the measurement, it'll simultaneously be sending that out to the LIMS database.
Yep.
Right.
So we can definitely, like, for example, if you had some results that didn't transfer over for whatever reason, network issues or something like that, you can grab like 10 different samples that didn't transfer over, and you can send it, and it'll go into it will be sent automatically into that folder.
Okay.
And be captured by your system.
So either continuous mode or batch mode.
Yeah.
All right. The next question from Natalie. Do you have a standard list program for the S6 Jaguar? I think we talked about that a little bit.
Yeah, so I just want to say, yes, we do. Again, in that case, you need to go with the 3 default crystals to cover the whole periodic system. But other than that, that's all what you need. You don't have to run any standards for that. It's standard list. We provide a check sample and we provide drift correction samples for that. But for you, that's why it's called standard list. For you as a user, it's hands-off.
All right. So the next question from Danielle. What type of X-ray sources are used in the S6 Jaguar?
I guess I can start with this one. So it's a rhodium tube that we're using. The power for the system is a 400 watt power, go up to 50 kV and 17 milliamps. That's the source that we're using. On our Tiger, we have the rhodium as well. On the Puma, we use either the silver or the palladium X-ray tube. Julie, you want to add anything else to that, or?
No, I think those are the standard tubes that we work with, and we have, I mean, we get great results with it. So they, I mean, never change a running system, right? We have been using the rhodium tubes forever, and we tackle all kinds of applications with it.
And in terms of it being a benchtop form factor, that 400 watts is actually quite powerful.
Yes, it is. So we do have a lot of customers who have an older 1 kilowatt system, but they only use it for one application, but it's kind of demanding. They need that resolution. So if they, for example, would consider what I need to update my system. Do I need another one, S8 Tiger, or should I look into smaller systems? So now the S6 kind of fills that gap, right? If you don't run 100 samples per day, but you still need that resolution, that's where the S6 is really perfect for you. So if you want to measure sulfur or phosphorus, and that's where you would need a special crystal, the germanium crystal, you can get an S6 Jaguar with just that one crystal. Installation is quick, you'll be running that same day.
And sometimes the name of the game isn't just power, right? It's also about the efficiency. So having a compact beam path, having the right crystal, having all these things really boost that signal, right?
Yes, correct.
All right, next question from William. What is the effective penetration thickness of this technique? So how deep do we get into that sample?
Depends on your sample. I don't know, Dan, do you want to answer it, or do you want me to get very theoretical?
How about maybe some guidelines? Like, so we had that steel sample that we were just looking at. How deep do we typically get there?
Well, it also depends on the steel sample, the density, and what elements you're looking at. Lighter elements penetrate, you're looking at more of the surface, basically, and heavier elements, you're looking further into your sample. For like a geological sample or a cement sample, this sample right here, we consider to be infinitely thick. Okay. If we're measuring oil samples and we're looking at sulfur, like half this cup here would be considered to be infinitely thick as well. So the samples don't have to be gigantic, but again, it depends on which element you're looking at, which line you're looking at, the K alpha line or the alpha line, and the density of the sample. Julia, you want to go in more in depth on that, or?
Yeah, what I would add is it's good if your samples are infinitively thick. If it's not possible, all of our software has the option of describing your sample geometrically. So you can either add 2 or 3 variables depending on how involved the correction needs to be. So you enter the diameter, how much you entered, and what the density is, or the diameter, how much you put in, and what the mass is. So with that, the software can calculate or can describe the sample that you're measuring and adjust the factors, the correction factors accordingly. And on the other hand, if it's not infinitively thick, we also can measure layers. And then from the response of the system, we can, for example, make a calibration of layer thicknesses. That's also possible.
Yeah, so like electron techniques, I know, they only penetrate maybe nanometers or so. You're really just getting the surface, which can be compromised from oxidation, things like that. Sounds like here you're going to really kind of get more of the bulk. You're going to get the microns to millimeters?
Depends, yes.
Yeah.
But yes, micron to millimeter sums it up pretty well.
But then if we want to be sensitive to something very, very thin, maybe you know, half a micron or so, we could still measure that. Doesn't preclude us
Correct.
from measuring
So
that.
hypothetically, you have something like you have paper and you coat it with something and you want to measure the coating thickness and you have one element in there, let's say it's phosphorus. The thicker the coating gets, if it's always the same material or it's always the same composition, from the response of the phosphorus, you can calculate the thickness.
All right, so I think we're running out of time here. If you have any additional questions, make sure to email them to live.events@bruker.com. Thanks, Julie and Dan, for joining us here on Live from the Lab.
Thank you.
And thanks, everybody, for joining in. And we'll see you next time. Until then, keep your signal high and your background low.
Goodbye.